Hi all, welcome back. So in last section we discussed about the rocket propulsion. So let's start with this one problem with the rocket propulsion. Okay. So a rocket fired vertically from the rest burned its fuel in 30 seconds. If the exhaust velocity of the gas relative to the rocket is 3000 meter per second, what must be the mass ratio for a final velocity of 8 into 10 cube meter per second? Okay, we know the equation. So this is a problem in the velocity of the rocket in free space, that is Vf is equal to Vf minus V0. Okay, so Vf is equal to V0 plus U log Mi by Mf. They have given the U, the exhaust velocity 3000 meter per second. So and we need to find the Mi by M or the M0 by M, that is the ratio of masses. They have given the final velocities, that is the Vf is equal to 8 into 10 cube. Okay, and since it is the as a rocket fired vertically from the rest, that means the initial velocity is 0. So by substituting it we get, okay, so initial velocity is given as 0. Exhaust velocity V is equal to 3000 meter per second, and V is equal to V0 plus V log M0 by M. Okay, so V is equal to 8.8 into 10 cube by meter per second. Okay, by substituting we get, okay, so converting this log E to the log 10, that is we are multiplying 2.303. We all know that 2.303 into log 10 M0 by M. Okay, from this calculation I'm not doing this, so we get the answer 14.38 will be the right answer. Okay, so remember this equation is very important, that is delta V or the Vf minus Vi is equal to U log Mi by Mf. Remember always that U is the exhaust velocity and delta V is equal to Vf minus Vi. Now we are going to discuss another concept, that is the central force or the central force problems. So what do you mean by central force? If a force acts on a particle in such a way that it is always directed towards or away from the fixed point, and its magnitude depends only upon the distance from the fixed point, then the force is called as central force. Okay, so that means if a force acts on a particle in such a way that it is always directed towards or away from that point, and its magnitude only depend upon the distance r from the fixed points, so mathematically a central force can be written as F is equal to F of r into r cap. But since F is only a function of r, that is the distance, we already said that it depends upon the distance from the fixed point, and r cap it can be written as vector r divided by modulus of r is the unit vector along the r direction. And also remember that if f of r is negative, then it is attractive, and f of r is positive, then the force is repulsive. Okay, so remember that central force. So remember what do you mean by central force? A force acts on a particle in such a way that it is always directed towards or away from the fixed point, and its magnitude only depend upon what the distance from the fixed point, then the force is known as central force. Mathematically, it is defined as F is equal to F of r into r cap, where r cap is the unit vector. And also remember that the central force is attractive if F of r is less than 0, and repulsive if F of r is greater than 0. Now, okay. And also remember this very important, that is in a central force problem, the angular momentum J is constant. Okay, that means for angular momentum J to remain constant, its magnitude and the direction should remain constant. We said that J angular momentum is a vector. It has both magnitude and direction. For the J to be constant, it should be constant in both magnitude and direction. So to keep the direction of the angular momentum constant, the particle has to move in a plane. Okay, In other words, the motion of the particle under the influence of a central force is two-dimensional. It's very important. So from the sentence of that, from the sentence that is in a central force, the angular momentum is constant. From this sentence we derive that in motion of a particle under the influence of a central force is two-dimensional. From where, for since angular momentum j is a constant, the constant means should be constant in both the magnitude and direction. So to keep the direction of the angular momentum constant, the particle has to move in a plane. Okay, or the motion of a particle under the influence of a central force is two-dimensional. Okay, now we are going to discuss the next topic. Mint. So let's discuss the escape velocity, or it is also known as the velocity of escape. Okay, so what do you mean by escape velocity or the velocity of an escape? So the minimum velocity with which a body is to be projected so that it never returns back to the earth is known as the escape velocity. That means if you consider a man at the surface of the earth, okay, so if I throw a ball, if a man throws a ball, okay, with a velocity v, so the ball will be projected that it never returns back to the earth is known as its escape velocity. So here v is the escape velocity. Okay, so the minimum velocity with which a body is to be projected that it never return back to the earth is known as escape velocity. Okay, now consider a body of mass m on the surface of the earth. Let m be the mass of the earth and r be the radius. That means if you consider the earth of radius capital R and mass capital M, consider a body of mass small letter m on the surface of the earth. Okay, so the potential energy can be written as minus g mm by r. We already know, we already studied in the small classes. Okay, potential energy is equal to minus g mm into r by divided by r. Sorry, m is the mass of capital M, be the mass of the earth, and small m be the mass of the body, and r is radius of earth. So suppose the body is given an amount of energy plus g mm by r. Okay, so the potential energy becomes 0 since it is minus g mm by r. If we given plus g mm by r, the potential energy becomes 0. Then the potential energy of the body due to the attraction of the earth becomes 0. The body has surely reached the beyond the gravitational field of the earth. That means the body never returns. This must be given to the body in the form of kinetic energy. Okay, that means if you consider a body of mass m on the surface of the earth, okay, then the potential energy is given by minus gmm by r. If we give an amount of energy plus gmm by r, then the total potential energy of the body due to the attraction of the earth becomes 0. That means the body has surely reached beyond the gravitational field of the earth. That means the body never returns. So this energy must be given to body in the form of kinetic energy. That means the gmm by r. You know the kinetic energy half mv square. Okay, half mv square. Here we take ve instead of v to represent the escape velocity. That's also equal to, we already said that what the energy must be given to body in the form of kinetic energy. So half mv square is equal to gmm by r. Okay, so by cancelling both m on both sides and taking the square root, okay, v is equal to root 2 gm by r. This is an equation for escape velocity. So the escape velocity only depend on what? It depend only upon the mass of the earth and the radius of the earth and the g. Okay, so near the surface of the earth, okay, so near the surface of the earth we can take acceleration due to gravity. G is equal to gm by r square, and here so gm can be written as gr square. By rearranging we get v is equal to root gr square by r, both r cancel out, and v is equal to root 2 gr. So remember this equation. Okay, it's really easy. Remember these two equation, that is, one is ve or the escape velocity is equal to root 2 gm by r, and also ve is equal to root 2 gr. Okay, now we are going to discuss the next topic, that is the orbital velocity. This velocity is related to or the motion of satellites. We know the satellites are revolving around the earth. Okay, so let m be the mass and v0 be the velocity of the satellite revolving around the earth in a circular orbit of radius r. I'll show you an image. Okay, so let m be the mass and the v0 is the velocity of the satellite revolving around this is earth. Okay, revolving around the earth in a circular orbit of radius r. Okay, this r will be from the center of the earth. Okay, so let if capital R be the radius of the earth, and from the surface of the earth the height will be h, so the small letter r can be written as r plus h. Okay, we'll show you in later section. Okay, so consider now, 1 minute. So now consider, let m be the mass and v0 be the velocity of the satellite revolving round the earth in a circular orbit of radius r. The centripetal force necessarily for the circular motion is provided by what is the gravitational force of attraction. Okay, we know if two bodies came together there will be a gravitational force of attraction. This we already said it in the small classes. It is m by r square. Okay, what is m is the mass of the earth, m is the mass of the body, and r square is the distance between the earth and the satellite. Okay, so we can write that is the centripetal force mv naught square by r is equal to gmm by r square. Okay, and from this we get v naught is equal to, that is, v naught can be written as velocity of the satellite root gm by r. We know. Okay, so also here we consider that the earth and circular orbit, here we consider the position of satellite. This total distance is considered as r. Okay, so this r will be the sum of capital R plus h. Okay, let h be this distance and r be the radius of the earth. So small letter r can be written as r plus h. Okay, so by rearranging, okay, so for the r is equal to r plus h, where h is the height of the satellite from the surface of earth, v naught is equal to root gm by r plus h. V naught is equal to root gr square. We know we can rewrite it, that is gm is equal to gr square, or acceleration due to g is equal to gm by r square. Okay, by substituting this we get v naught is equal to gr square by r plus h. Okay, what is the capital R implies? Capital R implies the radius of the earth. Now, okay, so let's find the period of revolution. So the time taken for one complete revolution is the time period of satellite. That means if you consider the earth an orbit, the satellite is revolving, the time taken to complete the one revolution is the time period of satellite. Okay, so we know time is equal to what? Time is equal to distance by velocity. So what is the velocity here? V naught, we already said that v naught is equal to root gm by r plus h. And what is the distance? We know, since a circular, we are considering a circular, we know the circumference equation. Okay, the 2 pi r radius, here the distance is r plus h, so 2 pi r plus h by v naught. We know the equation of v naught we already studied, that is v naught is equal to root gm by r plus h. So t is equal to 2 pi into r plus h divided by root of gm by r plus h. By taking the denominator, r plus root of r plus h to numerator, we get 2 pi r plus h all raised to 3 by t divided by root gm. And also by rearranging, we know acceleration due to gravity g is equal to gm by r square. From this, gm is equal to gr square. Okay, then t is equal to 2 pi r plus h all raised to 3 by t r root g. Okay, so and also we can rewrite it as by take r plus h can be written as r. Okay, so, and the equation will be t is equal to 2 pi r all raised to 3 by 2 r root g. So don't worry, okay, you only need to study this equation and you can derive easily from this equation, okay, according to a question. So t is equal to 2 pi r plus h by v naught. And also remember what is by v naught? It is the velocity of the satellite, that is given by root gm by r plus h. Now we are going to discuss the next topic, that is the Kepler's law. That is, there are three laws for Kepler's, that is the law of elliptical orbit, the law of areas, and finally the harmonic law. Okay, so let's first discuss the law of elliptical orbit. So every planet, the first law, that is the law of elliptical orbit, states that every planets move around the sun in elliptical orbit with the sun at one of its focus or foci. Okay, so every planet moves around the sun in an elliptical orbit with the sun at one of its focus. Okay, this is the law of elliptical orbits. Now the second law states that the law of areas, that is the radius vector drawn from the sun to the planet, traces equal areas in equal interval of time, that is the aerial velocity of the planet is constant. That means if you consider the elliptical orbit, okay, that means we have, for an elliptical orbit you have two focuses, then sun be at this one of the focus. Okay, let this be the position of planet. Okay, let this be r1, then the planet moves here, the planet reaches, now this be r2. So the radius vector drawn from the sun to the planet traces equal area in equal interval of time, that is this aerial velocity is constant. That means here I will show you this, since this is sun, this planet. Okay, since p1 moves, planet moves from position p1 to p2, let r be the radius vector. So the radius vector drawn from the sun to the planet traces equal area in equal interval of time, that is the aerial velocity di by dt is equal constant. Since we can write, since the angle we are taking the angle as d theta, okay, so half r square into d theta by dt is equal to d theta by dt can be written as the angular velocity omega. So half r square omega is equal to dA by dt is equal to aerial velocity is constant, is the second law of areas. Now finally the third law, that is square of time period of revolution of a planet around the sun is proportional to cube of the semi-major axis of the ellipse. That means the square of time period of revolution of a planet, that is the time, let t be the time period, then the square of time period means the t square is proportional to the cube of the semi-major axis of the ellipse. Let a be the semi-major axis of the ellipse, then cube means a cube, that is t square is proportional to a cube, is known as the Kepler's third law or the harmonic law. That means I am not deriving it. Okay, it's the final equation of the derivation, d square is equal to 4 pi a cube by gm. So from this equation 4 pi d square gm will be constant, so t square is proportional to a cube. Okay, so the Kepler's third law is proved. So we have three laws. The first law states that is the every planets move around the sun in an elliptical orbit with the sun at its center. Okay, you already know it. And the second law says the law of areas, that is the radius vector drawn from the sun to the planet traces equal areas in equal interval of time. It simply says that the aerial velocity is constant. the expression of area velocity is dA by dt, that is half r square d theta by dt, or half r square omega. And also the final law, the harmonic law, says that the square, that is the square of time period of revolution of a planet, proportional to what, the cube of the semi major or major axis of ellipse, that is t square, is proportional to a cube. Okay, thank you.